The dream of interstellar travel has captivated the imagination of humankind. Science fiction movies have painted vivid images of humans journeying to distant star systems, establishing colonies on far-off planets, and exploring the deep reaches of the galaxy. Star Wars makes it look easy with their massive spaceships that disappear so effortlessly using their hyperdrives to traverse across great distances. Humans have a fascination with visiting and seeing firsthand the amazing diversity of the Milky Way galaxy. But there may be a harsh reality that we choose to ignore for the sake of our curiosity. There are overwhelming obstacles that stand in our way for us to become a civilization that can cross the vast openness of space. Despite these seemingly insurmountable challenges, can humanity overcome them? Is interstellar travel a fantasy? Is it even possible? In Star Wars, they use a propulsion system they call a hyperdrive that allows their spacecraft to travel at speeds much faster than light. A ship can traverse 120,000 light-years in a matter of days or even hours. Hyperdrives have a navigation computer that calculates a safe path and a reactor assembly that generates the power using hypermatter. These are either coaxium or closen-36, rare and ultra-efficient matter that coats the main chamber of the hyperdrives. The hyperdrives allow ships to travel through hyperspace, an alternate dimension that's coterminous with real space. It sounds like a great way to travel from one side of the galaxy to the other, but there's only one problem. It's not real. It's all made up. Comic book writers and movie directors have a much easier task of explaining away how massive starships are able to travel huge distances to the other side of the galaxy. Astrophysicists and propulsion engineers have to conceive of ways that actually work and can be made and designed based on our current level of technology. The biggest challenge we face with interstellar travel is the sheer size of the universe. The distance between stars is so vast that even if we took our most advanced spacecraft ideas, it would take tens of thousands of years to reach the closest one. The nearest star to Earth, Proxima Centauri, is about 4.2 light-years away. To put this into perspective, 1 light-year is roughly 5.88 trillion miles. The fastest spacecraft we have ever built is NASA's Parker Solar Probe, which travels at around 430,000 miles per hour. At that speed, it would take approximately 17,000 years to reach Proxima Centauri. Even if we increase this speed by a factor of 100, it will still take 170 years to reach the nearest star. The sheer enormity of interstellar distances creates a time problem that no current or foreseeable technology can overcome. We need to develop a method to drastically reduce travel time between stars. Otherwise, interstellar travel will remain out of our reach. In Star Trek, Federation ships use what they call a warp drive. It creates a bubble that distorts space-time and propels the ship forward. The ships use an antimatter reaction, which is regulated by dilithium crystals, to create an enormous amount of power. This power generates electroplasma, which interacts with the ship's warp coils. These warp coils create a warp field or bubble that encircles the ship. This warp bubble compresses space in front of the ship and expands behind it. This in essence creates a shorter distance to travel. Warp 1 is equivalent to the speed of light, which offers very little benefit to the world that is shown in the Star Trek universe. But Warp 9 is 1,516 times the speed of light, which would allow a starship to cross the Milky Way galaxy in about 65 years. This makes the Star Trek Federation a regional space power that explores only a small part of the galaxy compared to the Empire in Star Wars, which is on the galactic level. The only problem with the Star Trek warp drives is that they sound plausible in a script and on TV. The actors need only talk about the warp drive engines, the matter-antimatter power converters, and dilithium crystals for them to work. But in the real world, the Star Trek method of traversing the stars gets humanity no closer to actually visiting our neighboring star systems. Star Wars hyperdrives are much more advanced than Star Trek warp drives based on how their engines perform, but both offer little more than science fiction and possibilities that exist only in our minds. Our current understanding of physics severely limits the prospects of interstellar travel. The speed of light, which is about 186,000 miles per second, is the universal speed limit, according to Einstein's theory of relativity. No object with mass, such as a spaceship, can travel at or faster than the speed of light without requiring infinite energy. Even achieving a fraction of light speed is a monumental task. Traditional rocket propulsion systems, which rely on chemical reactions, are not nearly powerful or efficient enough for interstellar voyages. Advanced propulsion concepts, such as nuclear fusion or antimatter drives, have been theorized, but these technologies are far from being realized. Building spacecraft that can travel at a significant fraction of the speed of light would require massive breakthroughs in energy generation, material science, and engineering. Another problem? Space is not empty. It contains dust, gas, and particles, all of which become dangerous projectiles at high speeds. Traveling even at a small percentage of the speed of light would cause catastrophic collisions with tiny particles, creating damage to the spacecraft that we currently have no means of mitigating. Developing technology that can protect spacecraft from these collisions is another hurdle that we are nowhere near overcoming. The energy requirements for interstellar travel are staggering. To accelerate a spacecraft to even a fraction of the speed of light would require an amount of energy far beyond what humanity currently produces. To propel a spacecraft to just 10% of the speed of light, we would need all of the energy consumed by the entire world for 3 or 4 years. Any spacecraft traveling at such high speeds would then require even more energy to decelerate once it reaches its destination. The problem of energy management, both for acceleration and deceleration, presents massive obstacles to interstellar travel. But let's speculate that even if we could develop a spacecraft capable of traveling vast interstellar distances, the human body poses the next huge dilemma. Our bodies are not designed for long-term space travel. The lack of gravity would cause muscle atrophy and bone loss, while exposure to cosmic radiation increases the risk of cancer and other diseases. There is the problem of time dilation, as described by Einstein's theory of special relativity. As an object approaches the speed of light, time appears to slow down for that object relative to an observer at rest. In theory, if a spacecraft could travel close to the speed of light, the crew on board might experience a much shorter journey than people on Earth. Even if the crew only experienced a few years of travel, by the time they reached another star, many generations would have passed on Earth. The people they left behind would be long dead, and the world they returned to, if they ever did, would be unrecognizable. The sustainability of long-term space travel is also a critical challenge. Maintaining life support systems, food production, and energy sources over such extended periods presents enormous technical and logistical challenges. Spacecraft would need to be entirely self-sustaining, with closed-loop systems for air, water, and food. Any breakdown in these systems would spell disaster for the crew. Star Wars and Star Trek give humanity the most effective methods of traveling the galaxy to visit new worlds, the power of our imagination. If there was a creator to our universe, a God that designed all things, it would appear that he made sure that civilizations would never have the opportunity to visit one another. He made physical laws that in themselves produce barriers for interstellar travel. Biology that makes it so that our bodies can only exist comfortably within a 1-mile band around the Earth, and distances so vast that they are incomprehensible to even imagine. Humanity's exploration of the cosmos may very well be limited to our solar system, with plans of visiting distant stars remaining in our dreams and Hollywood movies. We hope you enjoyed our exploration into interstellar space travel and invite you back to experience our next episode of A Godless Universe.